All right. Next example we're going to go over is same idea. We're going to be graphing linear relations, or in other words, lines. But we're going to use slope y-intercept. Okay. So again, we've been given our graph, and this time an equation. Now, when looking for slope y-intercept, our goal is to set it equal to something. Does anybody know what? Before we do anything else, we want to rearrange this equation. We want to set it equal to something. Okay? Okay, so we do want to move the x and the constant number to the other side. But not only do we want to just have 6y, we want to have y completely by itself. Okay? And you know what I'm going to do? Just so it's a little easier, I'm going to change that number to 6. Just so it's a little nicer to work with. Okay? It's not a big deal. So, our goal is to set this equal to y. This entire equation. We want y by itself, which is essentially what we were working on yesterday. So what that means is the other two terms, 3x and 6, we want to move them to the other side. And again, remember, we're creating zeros. Okay? Now, normally, the way you guys look at it is because it's a positive sign, it becomes negative on the other side, so we get negative 3x and negative 6. But I actually quickly tell you exactly what we're doing. What we're really doing is we're applying negative 3x to both sides of the equation, and these create a 0. Okay? Same idea with here. We're actually subtracting 6 and subtracting 6. Because if you guys remember, with balancing equations, whatever you do to one side, you must do to the other. Okay? But the only thing is when we subtract by 6 and subtract by negative 3, we end up with 2 zeros. And when you add 0 and 0, it doesn't change what was already there. So the quick way of going about it, if they would have showed you a shortcut, is just moving things to the other side of the equation. Okay? So when we move those, we're left with 6y is equal to negative 3x minus 6. That's just our shortcut way. And we still need to get y by itself. So again, we need to divide everything by 6 in order to do this. Well, that's going to give us y is equal to negative a half x minus 1. Okay. Now, this is the form where we can use slope y-intercept. Because it is set equal to y, I have a slope. Anyone know what the slope is in this case?
1 over 2.
Negative a half. And anyone know what the y-intercept is? Negative 1, exactly. If you recall, slope y-intercept form is written like this. Y is equal to mx plus b, where m is our slope and b is our y-intercept. Okay? We'll color code those for you. So m was our slope and b was our y-intercept. This is a quick way to graph, especially because it usually does not take very long to set something equal to y. And instead of plugging in many numbers like we did with a table of values, here we just find the y-intercept, which is negative 1, and then we follow the slope. Remember, slope is also known as what? Something over another. Rise over run. Okay? And rise over run works great, especially when we have fractions. So if our slope is negative 1 over 2, it's also known as our rise over our run. Okay? This negative, I can technically apply it to the top or the bottom, but I don't apply it to both. Okay? And we'll talk about that in a second. So our y-intercept is here at negative 1, and our rise is down 1. Our run is over 2, 1, 2. So here's our next point. Then from there, we follow the same pattern. We go down 1. Okay, so we go down 1, and then over 2. This will be our next point. Down 1, over 2. We'll fill in those points. Okay? Looks like that. And that's when I was applying the negative to the top. Okay, we had negative 1 over 2. Or, I could have 1 over negative 2. I'm going to show you, again, that's still going to work because in this case, our rise is positive 1. So we're going to go up 1 from that spot. And our run is negative 2, so we go back 2. That still falls on the exact same line. Up 1, over 2. So it doesn't matter where we apply the negative. We're still going to end up on the exact same line. Okay? Reason being, if you guys remember your rules for integers, this is a negative, and a fraction is a division sign. So a negative divided by a positive is a negative, or in this case, a positive divided by a negative is still a negative. I cannot apply it to both. If I apply it to both from integer rules, a negative divided by a negative gives us a positive answer, and this is not a positive slope. Okay, negative slopes always head back in this direction, positive slopes in that direction. So just a side note there. So this is our slope y-intercept form. We have our line, and that's the entire page. A lot quicker than using a table of values.